In a recent comment, someone asked about simulating realistic snowfall, and that sparked an idea in me that I like to call Smol MPM. MPM simulations that are fast, don't produce huge amounts of cache data, and are fun to tweak and play around with. And this is our first project, which in the end took around 10 minutes for me to simulate and produced around 5 GB of cache data. A good start, but I think we'll build even smaller setups in the future. Let's jump in. So, in a not quite empty Houdini scene, I have one geo folder, and diving inside, I have a twig that I got from Polyhaven, and then I did some changes to that twig, mainly removing leaves, changing the UVs, and stuff like that. This is not important for today. You can use whatever twig you like. This is just the one that I'm going to use. And first of all, with that twig, I want to create some static snow that's already on top of that twig. Because I tried simulating that with MPM as well, and that would just take way too long. So let's just quickly build a sub setup to build a little snow coverage on that twig. Starting out with a node called mask by feature. Because what this node can do, if I set my display flag here, wire it in, and change into my handles tool, it can select the top faces of my object or the top points and create a mask attribute on them. And this is quite good for simulating the buildup of snow. Now, I do want to change that mask attribute up a tiny bit with some noise. And for this, I want to use an attribute adjust float, which is quickly becoming my favorite node for just making changes to general float attributes. So let's bring this node in. Let's go into the parameters. And also, I think on the mask by feature, I want to adjust the angle a bit. I used 60 degrees instead of 90 in here, and this worked a bit better for me. And then again on the attribute adjust float, I want to change an attribute called mask, because this is what this node is creating. I want to set the operation to multiply, so multiply it with some value that I'm generating here. And I want to set the value to noise. And then on the noise, I want to tweak the ramp in here a bit. I want to select the beginning point of that ramp and move it in to 0.15. And then I want to also adjust the element size and the offset, so the element size to 0.6 and the offset to 1. And this looked nice in the end, in my opinion. Now, to actually make use of that mask attribute, what I want to do is I want to use a scatter node, and this will sort of simulate snowflakes landing on that twig. On the scatter node, I don't want to force a total count. I want to have a general density for my snow. And for this, I'm going to use the density scale and turn this way up to 1 million. And after a bit of waiting, we do have loads of points now on our twig in here. Now, I also want to adjust the density by an attribute, so let's enable this in here and select our mask in here, and now this is starting to look like snow coverage. And I also want to turn down the relax iterations to 2, which looked again nicer in the end. And then finally we can turn these points into snow, or at least something that looks like snow, with a VDB from particles node. However, before we can plug this in, we do need a p-scale attribute on all those points, and for this again I want to use an attribute adjust float. And in here the only thing that I want to change, because we're already setting a p-scale attribute on point level with a constant value, I want to set this constant value to a 0.005 in here. And finally, I can plug this into my VDB from particles. Currently we see nothing because the voxel size is way too big, but if we make it smaller, 0.002 maybe, now we get something that actually looks like snow coverage. And we can smooth this out a tiny bit with a VDB smooth SDF node. And the default values in here I think should be fine. And yes, this is our first layer of snow. Of course, we don't want one layer of snow, we want multiple layers of snow. So what I want to do next is I want to take all of this in here and run it in a loop over and over and over again to pile up snow on this twig right here. And for this, we're going to use a for loop. Let's grab a for loop with feedback. Default values in here are fine. And what I want to do inside that for loop is I first of all want to branch out and I want to convert my VDB back into my mesh. Let's use a convert VDB node for that and set the type to polygons. And then I basically want to do the same things that I did up here down here in my loop as well. So let's hit just Control Z and V on all of those nodes. Let's wire them in below my convert VDB node. So I have another layer of snow, and I want to combine this with my first layer of snow with a combine VDB node. VDB combine. Let's wire this in here. Let's wire up the second input as well. And let's set the operation to an STF union. And now if I jump to the very end of this node, yeah, we have something that actually looks quite convincingly like a snow buildup. The only thing that I changed in the end is I disabled the first attribute noise up here to have at least a tiny layer of snow on my twig as well. And I think this looked a bit better. But with this now done, what I can do is I can drop down a reference null, and I'm going to call it snow_base like this. Now we also need some snowflakes, so let's create those next. For this, I want to start out with a grid first of all, and I want to ghost the twig in here. And let's make sure that the grid is on top of my twig by setting the size to 1 and 2 and the center to 1 and 1 along the Y and Z axes, like this. And then to make snow fall, all I need to do is drop down a scatter node, which will be the starting point of each snowflake. And in here I want to force the total count to 2, just 2 snowflakes per frame. And I want to change the global seed with each frame. So let's write a $f in here and let's turn off the relaxed iterations. And if I turn on the point display here and jump through my timeline, every frame I get a new starting position for each snowflake. Now, this is the physically accurate way of getting snowflakes. However, this is not a particularly interesting way of getting snowflakes because a ton of those snowflakes will just miss our twig. So let's make the simulation a bit more interesting by making sure some of these snowflakes just really land on this twig as well. So what I want to do for this is I want to start out with a peak node and I want to wire in my twig in here. And then on this peak node, I want to use this to enlarge my twig at least a tiny bit. Let's go to distance and let's set it to 0.01. And then I want to use a transfer node to flatten my twig along the y-axis. So let's set the y scale to 0. And then again, let's move it up to the same level as our main grid. So let's set the y position or the y translation to 1 as well. And now I can use the same scatter node. I can just duplicate it and I want to scatter for each frame 3 points on this twig geometry that I generated in here. And since this is the sort of 2D projection of our main twig here, for every frame we're making sure that we're spawning 3 new snowflakes that have a much higher chance of landing on our twig, which will make our simulation in the end a whole lot more interesting. Let's merge both of our scatter nodes together. So these are all the snowflakes that we're spawning per frame. And then again, let's adjust some attributes. First of all, I actually want to get rid of all attributes. So let's use an attribute delete node for this and say delete non-selected. And now we just have one single p attribute. And then I want to set a p-scale attribute. So again, attribute adjust float. It's already set to p-scale. I want to set the operation to set always. And I want to set a random p-scale. The minimum value, what I found worked nicely, is 0.005. And the maximum value is 0.02. So fairly small values. And the only other thing that I want to change in here is I want to animate the seed. So let's again add $f in here so that the sizes of our snowflakes also change with each frame. And finally, we can create our snowflake mesh. Let's make some more room in here and let's clean this up. And for my snowflake mesh, what I want to use is a sphere. On the sphere, let's set the type to polygon. Let's give it a frequency of 3. And I want to just crunch it down on the y-axis a bit. Make it flat like this, and I think this looked a bit more accurate. Now I'm going to take this sphere right here and copy it onto each point. Let's use a copy to points node for that. And here are our spheres as our snowflakes. And then I want to vary the shape of them by just using a mountain node, wire this down below. And on the mountain, I want to turn off noise along vector. I want to set the amplitude fairly low, 0.05, worked nicely for me. And I also want to turn down the element size to 0.14. And then finally, I want to also turn on animation to make the size varied, or the shape varied, and then under fractal, let's make sure that the roughness is set to 0.4. And if I zoom in on some of those snowflakes, they now look a lot more irregular, which is exactly what I want. So we're done here as well. we can drop down another null, and let's call this null snow underscore flake like this. And we're finally at a point where we can start out with our NPM simulation. Taking a high-level view at my null graph now, we have one reference null for our twig, we have another reference null for our snow base, and another reference null for our snowflakes. And for now, I want to create object merge nodes for each of them to keep the scene nice and clean. Let's create one for our twig by just dropping down object merge node and grabbing our twig null and dragging it in here. And let's also create one for the snow base and one for the snowflakes, and these will come in handy later. But now let's search for npm configure to get a base npm simulation network set up. And this right here looks promising. And now let's start populating our different sources and colliders and the container as well. Let's get rid of the input objects. And first of all, as a source, I want to have two sources, one for my snow base and one for my snowflakes like this. Let's take a look at the snow base first. We already got our particles in here, however, they are way too large. So what I want to do first is I want to go to the npm container and take a look at the particle separation. And the particle separation that worked nicely for me here is 0.002, fairly small. Now, while building the setup, I did most of my tweaking with a particle separation of 0.004, about 70%, and then the last 30% of tweaking I did with my final particle separation in here. And this still seemed relatively fast for me. Let's take a look at the npm source again. I don't want to change much in here. We're already using the snow preset. However, this is set up to sort of simulate quite heavy and dense snow. And what I found better for snowflakes and this sort of fluffy snow, turn down the density a whole lot, maybe down to 7. And then also turn down the stiffness a whole lot. In this case, for my base snow, a value of 0.002. And this created in the end the sort of powdery snow that just about stays together, but once it gets knocked down, we get just a ton of tiny, nice looking snowflakes or snow dust, which is exactly what I want. This is all we need to set up in here. The only thing that I also want to simulate right here with this snow is I want to simulate the bottom layers of this snow to be a bit more firm, a bit more compact. And what ended up working nicely for me to recreate this is to duplicate the reference to my twig up here and then measure the distance to that twig with a distance from geometry node, wherein the output of our npm source in here and the twig goes into the second input. And I just want to calculate the distance from surface. And now if I quickly create a visualizer for this dist attribute that got created in here, we can now see that the bottom layers get a lower distance attribute than the upper layers. And what I can do with this is I can use this distance attribute to change some of the npm attributes. And for this, I'm going to use the attribute remap node. Let's get rid of the visualizer for now. And I want to input my distance. I want to compute the range from the distance. And the thing then I want to put out is the density. And the lower value should be a value of 3. And the upper value should be a value of 7. And this was a sort of density range that resulted in more stable snow here at the bottom and less stable snow here at the top. We're done with our first source. Let's take a look at our second source. And yes, this is one of our snowflakes. Just a couple of particles. Look nice in the end. Now for my values in here, I pretty much want to use the same values that I set up in here. So let's just copy this node right here and plug this in. The only thing that I want to change in here is I want to change the stiffness. I want to make them a bit more fluffy, decreasing it to 0.001. And then scrolling up on the parameters, I want to set the emission type to continuous. And I want to make sure that the activation is set to 1. So each frame, we're going to add new snowflakes to our npm solve. And then since those snowflakes are already falling, I want to give them a bit of a initial velocity. So for this, let's use a point velocity node. Wire this down below, and let's set it to value, and the value shall be -0.1, like this. So finally, we can take both of our geostreams here, merge them together, and then this can go into the source of our npm solver, like this. Next, let's work on the collision. So for this, let's get the reference to our twig in here and just wire it into the npm collider. let's take a look at the collision volume, and this looks good. And the only thing that I want to change in here is just the friction and the stickiness, because again I want to have my static snow stick on top of this twig. Let's just put both of them to the maximum. However, in testing, these two values didn't do that much. What ended up working the best for making sure that the snow stays on top of a twig will be setting sleeping on our NPM particles as well, which we're going to do later. And finally, let's take one last look at our NPM container and see if we missed something in here. And no, I just changed the particle separation up here. So let's finally take a look at the NPM solver in here as well. On the solver, on the first tab, on forces, what I did is just up the air drag to a really high value of 20, because again, very light snowflakes, lots of air resistance, that sort of looked nice to me. Then on the collision, I do want to use a ground plane, however I don't want to use it to bounce my particles, I want to just delete them once they leave the frame, and I want to move it down to -1 like this. Then under advanced, we can of course set the cache. I'm going to set this to 30,000 megabytes. And then we can finally take a look at sleeping. And sleeping is something that we can find on the main solver tab, and is something that got added with Houdini 21. So make sure that you're using this version. In here, I want to enable auto sleep. And basically what this is doing is it takes a look at each particle, and if a particle is not moving much, then it just gets excluded from the simulation. And this makes, on the one hand, sure that our simulation load is pretty small. We're just simulating the particles that are actually moving, but it also does wonders in making sure that most of the snow is actually staying in here on our twig. I want to set the initial state to active, so my particles start active, but if they don't move, they get turned to sleeping particles. And I want to work on the velocity threshold, so which velocity it takes to wake them up or put them to sleep, and I want to turn them down to 0.01 like this, and this just worked nicely for me in testing. The last thing that we can set if we're working with sleeping particles is we can set a visualizer to make sure our system is working. And on the visualizer, we want to enable color from attribute, and the attribute that we want to visualize is the state attribute. This has a value or minimum value of 0 and a maximum value of 2. And all this means is if a particle has a value of 0, it's sleeping. If it has a value of 1, then it's active, and if it has a value of 2, it's a so-called boundary particle, which is currently sleeping, but really close to some active particles, so it might get active at some point. And this is all that we need to set in here. So finally, we can zoom out a bit, we can save our scene, we can keep our fingers crossed, and we can hit play on our timeline and see if our simulation is actually working. And I just paused it right here. If we take a look at our particles, a bunch of them are already sleeping, and this will sort of grow to more of these large pillars of snow right here, making sure that they're stable. A couple of them are falling down, but this is fine for me. This just adds to the realism. And then we also have our snow in here falling down, and some of them are already landing on a twig and settling there. So this looks good. At this point, we can cache the whole thing out. However, I won't bore you right here while caching this. I'm just going to load in a file cache. Let's drop down a file cache node in here, and you would just wire it in and hit save to disk in here. However, I'm just going to say load from disk and select the right one. This one right here. And if I play this now, as you can see, our sleeping is working, but we still have enough active regions so stuff can happen. And what I really like about this particular simulation is right here, right now at the end, this part of our branch is collapsing and a huge bank of snow is falling down, which I think looks really nice and really pushes this snow simulation up from your typical pop simulation that you typically see. So at this point, it's just about post-processing and then also rendering. So let's speed run through this. First of all, I wanted to take my simulation in here and remove the first couple of frames where these snowflakes are just starting to fall down. So for this, I want to use a time shift node. and just shift the entire simulation forward 55 frames by just going to the expression right here and adding to it 55 frames like this. Then I also found this simulation runs a bit fast for my taste, so I wanted to make it slower, and for this I used a time warp node. On here set the evaluation mode to by speed. Let's set the input and output frame range to our whole timeline, so 240 and 240 frames, and let's set the speed to 0.75 like this. Just make it a bit slower. And we also want to interpolate between those frames, and linear is fine. And our simulation is a good bit slower. Let's also get rid of some unused attributes to just make our scene a bit lighter. And the only attribute that I really want to get rid of is the CD attribute in here to get rid of these false colors. Then, since we used a time warp in here to slow our simulation down, we also need to adjust our velocity vectors to make the motion blur later while rendering look correctly. So for this, again, let's use an attribute adjust node. In this case, just an attribute adjust vector. This is already set up to work on the velocity, and the only thing that I want to do in here is set the adjustment to length only to adjust the speed, setting it to multiply, and in here plug in the same timescale, so 0.75 like this. And now we need to turn those particles in here, those grains, into actual snowflakes. And I was so sure that I would get out our old snowflake growing tutorial and maybe use some corps to generate really nice textures from that. However, while testing this setup, I built a really quick and dirty snowflake. This thing right here that you can also find in the scene file downloads. And actually, this ended up working perfectly while rendering. This looked really fine without getting any more complex, so this is just what I stuck with in the end. So to get this on our points, I want to use a copy to points node. Before we wire this in, let's make sure that we enable pack an instance to make this more efficient, and let's wire in our snowflake in here and our particles in here. And this is already looking kind of okayish, but we do need to make this a bit more random by first of all varying our p-scale a bit. So again, for this, adjust float. Let's work on the p-scale. Let's set the operation to multiply, and let's multiply it with some random values. Let's set the min value to 0.5 and the max value to 1.5. And I want to adjust the ramp a bit by just adding one more point in here and sort of dragging it down like this. But the main thing that I want to do is in here by randomization by, I want to select a custom attribute and make sure that we're using an ID attribute, which we should have on our GeoStream right here. And this will make sure we don't get any flickering. And I want to adjust the orientation as well, which is currently stored in an orient attribute right here on our GeoStream. So to adjust this, let's use an attribute randomize, because I think there's no adjustment node for quaternions. And in here, make sure that we're working on orient, that we set the operation to add value, that we set the minimum value to -1, and under options, that we enable a seed attribute in here as well. And this, in the end, in here is our final snow. So we can drop down another null, another reference, and let's call it snow, like this. Now, this is our whole sub setup done. We have our preparation up here. We have our MPM solve in here. We have our post-processing in here. The only thing left to do is to talk about rendering. And for this, we're going to go to the stage context, and I'm mainly going to paste the nodes that I used in the end, because to 90% this is just a bog standard camera render setup. There's just a couple of tiny things that we need to talk about. Let's quickly fix the references, because in here we used a Geo1 node, not a Geo4 node for our twig and our snow. And this is our scene right here. And if I take a look through my camera and go into the camera XPU mode, and wait a bit, we should see a pretty beautiful rendering appearing. So what did I do to achieve this rendering right here? Again, for the most part, this is just your bog standard camera setup. You're using sub import nodes to import the objects or the references to our objects. We have a camera node in here, we have a material library, we assign to the different objects that we're creating, and then we have just a simple HDRI to light the whole thing, again from polyhaven.com. And then we have our camera render settings. The few things to keep in mind in here. On the sub import node to import our snow, what we want to do is we want to go to the primitive definition, and under pack primitives, we want to create a point instancer, because change to the Solaris viewport and take a look at the scene graph tree. If I go to my snow, now I have this point called instances, and inside that instances under prototypes and under object 0, I have the one mesh of the snowflake. And this is also the mesh that I can drag in here into my snow material and assign the material to this object, and it will automatically get assigned to every snowflake in my scene. Now, speaking of materials, let's take a look at them. Again, just 3 materials, one for the background, one for the twig, and one for the snow. These are bog standard Disney principal shaders. However, the snow is quite interesting because this is maybe the most insane material that I ever built. However, it worked pretty nice. So what do we need to do to simulate snow? Well, first of all, we should make it white so that it's really, really nice and bright and white. So we go to the base color and we set it to white. Then it's also reflective, so we need to go to the specular and turn the roughness down to 0. And now it starts getting insane. So first of all, we do need some subsurface scattering. This makes also sense. So we go to subsurface and we set the subsurface ratio to 0.5, which worked nicely in my opinion. And let's also make sure that the color is also set to white in here. However, to make our snow even whiter, because at that point it was a bit grayish, I also turned up the emission just a tiny bit. And also, since the subsurface scattering wasn't quite enough, what I did as well, and this is a trick from my last snow tutorial, which I learned there, is to turn down the opacity to 0.4. And also for the subsurface scattering that we used before, let's also turn on thin wall to make it accurate. So again, absolutely insane material, not physically accurate in any way, but in the end it looks like snow, and this is what counts for me. And then finally, the only other thing that we need to take into account here is down in the camera render settings, under camera effects, we need to enable motion blur and velocity blur right here, and also instance velocity blur right here. And this will make sure that we're using the right sort of motion blur for the scene. And this is the whole scene done. So a fairly fast, fairly lightweight MPM simulation that's quite fun to tweak, and I think in the end produces good results. So that's everything that I have for you today, and it's cheers and goodbye. And if you like us and want to support us, maybe consider becoming a patron of ours as well. And to all our existing patrons, thanks guys. Without you, this video right here would not exist. Thank you.